Now that you have understood what mass spectrometry is, let's dive in a little deeper into this procedure, shall we? In this device, the substance that we want to analyze is first converted in its vapor state by keeping the pressure of these vapors extremely low, like about 10 raised to the power minus 6 to 10 raised to the power minus 7 torr. Next, the vapors enter the ionization chamber where they are bombarded with high-speed electrons to form positively charged ions. You see, this is how atoms of elements are ionized. Now, these ions will have different masses. The third step is the acceleration of these positive ions. But how can we achieve that? When a potential difference of 500 volts to 2000 volt is applied, these positive ions get attracted to the negative plate, and in this way these positive ions are accelerated. Pretty simple, right? After acceleration, these ions are passed through a strong magnetic field, where they get separated based on their mass to charge ratio values. In magnetic fields, these ions move in a circular path, which causes separation. So, the isotopes which have same mass over charge ratio m over E will move in separate groups, falling on the electrometer after one another. Mathematically, this ratio is expressed as mass to charge ratio equals to h square multiplied by r divided by 2e, where h is the strength of the magnetic field, r is the radius of the circular path, and E is the strength of the electric field. You must know that if any of these values increase or decrease, it will definitely affect the other value. What I am trying to say is, if, for example, I increase the strength of the electric field, that is E, keeping H constant, the radius will increase. So, when the magnetic field is applied, the ions begin their movement in a circular path in the form of groups depending upon their mass to charge values. Similar ions having the same mass to charge values will form groups one after the other and fall on the electrometer at different positions. To clarify, the electrometer collects ions, therefore it is also called the ion collector. It develops an electric current too. A minute electric current is developed by each ion as well. Now, this strength of the electric current is the deciding factor of the abundance of ions. This simply means the greater strength of current means more relative abundance of that particular ion of the isotope. Isotopes of different masses fall on the ion collector and their current strength is measured. This way, we get the relative abundance of each type of isotope. I assume things are transparent so far. After all this procedure is concluded, the same experiment is performed with carbon-12 isotope. Guys, do you remember we are comparing all these elements with the carbon-12 isotope? This comparison allows us to measure the exact mass number of an isotope. If the smaller the mass to charge ratio of an isotope, the smaller will be the radius of curvature produced by the magnetic field, in accordance with the equation we just discussed. Don't be confused and rewatch this part of the video again to understand it more clearly.